Hello there. In this video, we are going to be learning about expanding brackets. So there are a lot of different situations you'll see expanding brackets in, and it's a very vital part of algebra. So to begin with, we're going to learn about situations where we have one term on the outside. Okay, so we'll go through a few examples and yeah, so expand, it'll normally say expand and simplify, which means we have to expand the bracket and then we need to try and make it the neatest possible answer afterwards. So let's start with this first example. So here you can see that we have one term on the outside being this x, and then we have what's called a binomial. You don't need to remember this name, but it's basically the bracket bit. So this bit. And when we expand it, we want to multiply the term on the outside with each of the terms in the binomial. So if I color code it, we have this first one. So we're multiplying the x by the first term, which is also x. And then what we're going to do is we're going to multiply it by the second term as well. So we just multiply it by each of the terms. So now if I do this, the first bit will be x times x because we're multiplying this bit on the outside by the first term. And then we have a negative here, like that. And then we have the second term, which is x times by 2, like that. So what will happen is we'll end up with x times x is x squared, and then we'll get minus, and then we have 2 times x, which is just 2x. So this is our answer here. So you can see, at least here, that this term on the outside is being multiplied by this first term here, and then it's being multiplied by this second term. Okay, so now let's do it again for this, this second one. So it's much the same thing. So we have this term 4y on the outside, and we just have to multiply it by each of the terms, like so. So what do we get? We get 4y times by 2y, so that's our first term, and then 4y times by 6, which is our second term, and that equals 8. This first bit equals 8, and then we have 2 y's, so that gives us y squared. And then the second bit, we only have 1 y, and then we have 6 times 4, which is 24y, like so. So that would be our answer. Right. Let's move on. So this is a tougher example. It says expand and simplify this. So again, we have one term on the outside, which is our xy. And then we have this term, which is x squared minus 2x plus 5. But the process is exactly the same. So we just multiply each term by, in fact, I'll show it here. So we multiply each term by that first term in the front. So it doesn't matter how many terms there are, we'll still be multiplying each of them by that, by the term at the front. So let's do that. We have xy multiplied by x squared. And then we have x minus here, and then we have xy multiplied by 2x plus we have xy multiplied by 5, like so. And you can see that we have xy multiplied by each of the terms in the bracket. So let's tidy that up a bit. So x squared times x is x cubed. So we get x cubed y. And then here we have an x on the here we have an x on the right here. So that multiplies with this x to give us x squared. So we get minus 2x squared y. It doesn't matter which order you put the x's and y's, but we tend to do it in alphabetical order. And here we're just multiplying, with the third term, we're just multiplying xy by 5. So we get 5xy, like so. Okay, now let's look at expanding binomials. So now we don't just have one term at the front. We have this. It's a binomial at the front. So in a similar way, what we do is we multiply each of the terms at the front, each of the terms here with this first term, and then each of the terms of the second term. So I'll show that. So first, what we want to do is we want to multiply each of the terms with the front term, so x in this case. So we'll get x times x is x squared, x times 3 is 3x. And then we want to do it with the second term, like that. So we get 2 times x, which is 2x, and then 2 times 3, which is 6. So you can see that we've just multiplied this first term by each term in the second bracket, and then the second term by each term in the second bracket. And here, we're actually not done, because remember, it says to simplify. And this isn't in its simplest form, because we have two x terms here, which we can simplify. So 3x plus 2x is 5x. So we can simplify that like so. Okay, so here, in the second example, we have a plus b squared. But if you remember, squaring something is the same thing as multiplying it by itself. So whenever you see a binomial squared, you can write it as a plus b times by a plus b. And now it's in the form we know. And now if this top method is a bit confusing, you can use this more guided method called FOIL. And FOIL basically stands for firsts, outers, inners, lasts. And I'll show you what that means. So the firsts mean the first term in each of the brackets. So that's our F. And then our O are outer terms. And the outer terms are the ones on the outside. So our leftmost term and our rightmost term. And then so that will be O. And then we have our inners, which are the terms that are closest to the middle. So that's our inners, I. And then we have our lasts. And those are the two terms at the end. So those are our lasts. So you can always use that to figure out which ones you have to multiply if this top method is confusing. So for F, we have a times a, which is a squared. For our O's, our outers, we have a times b, which is just ab. For our inners, we also have a times b, which is ab. And we have, for our lasts, we have b times b, which is b squared. So we get a squared plus ab plus ab plus b squared. In other words, we get a squared plus 2ab, because remember, these two are the same term. They're both ab terms, and then we just have b squared. So that will be our final answer. Okay. Now we're going to learn about something called difference of two squares. And basically what this means is, well, we'll learn about the rule in a second, but we're just going to expand and simplify like we have learned so far. So let's multiply a by the second two terms in the brackets. So we'll get a times a, which is a squared, and then a times minus b, remember, because there's a negative. And then that will give us minus ab. And then what we get is we're going to multiply this second term by each of these. And then we get, what we get is a times b, which is ab. And then we get b times minus b, which is minus b squared, like that. And you can see now that minus ab cancels out with the plus ab. So we just get a squared minus b squared. And this is the difference of two squares. It states that if you have a plus b times a minus b, you get a squared minus b squared, like that. So this is a nice rule that we can use to kind of skip a few steps. So if you ever see something in the form like this, for example, let's say you get x plus 2, x minus 2, you know that if we look at the right-hand side here, we know that that's the same as saying x squared, because that's a squared, minus 4, because that's 2 squared. So that's what we can use it for. Now, here I've put check, which basically means that how are we going to check all of these? Well, in the next video, I'll talk about factorization, which is a method that we can use to actually check all of this. So let's move on. Okay, so this is just a higher topic, triple brackets. So if you're doing foundation, you can skip past this section, but you can look at the end of the video because there are a few exercises. Okay, so now triple brackets mean that we have 3 brackets here. We don't just have 1. So how are we going to deal with this? Well, it might look pretty complicated, but actually it's not that bad. You just have to do 2 steps. So first of all, you want to get your simplest bracket. So in our case, x plus 1 seems simple because it doesn't have any negatives. And also, they're nicer numbers, 1 and x, rather than 2 or 3. And you want to isolate that. And now, yeah, so we isolate it. So let's just look at these two. So now x plus 1, we're kind of going to forget about that for a bit. And now we're going to find out what x plus 2, x plus 3 is. So we know how to expand this because it's something that we've done. Okay, so let's expand this. So what we get is x times x, which is x squared, x times 3, which is 3x, 2 times x, which is 2x, 2 times 3, which is 6. We get x squared plus 5x plus 6. We've actually done this question previously. So now that we have that, we can substitute it in for this bit in the red brackets. So now we have x plus 1 multiplied by x squared plus 5x plus 6. And now what we can do is we can multiply the x with each of these terms. In fact, I will do it in green. So we're going to multiply it by each of the terms. Just because there are 3 terms in the second bracket, it doesn't matter. We still multiply the first term, so the x, by each of these, and then we multiply the second term by each of these. So actually, I'll do it step by step. So let's get rid of these. So our first step is to multiply this x by the first term, which will give us x cubed. And then we want to multiply it by the second term. So we have 5x squared. And then the last term, so we get 6x. And then we multiply everything by this 1 here. So we get plus x squared. And then we multiply it by the 5x. And then the 6. like that. Actually going to move these down a bit, like that. Yeah, so now we can tidy this up a bit. We only have one x cubed term, but we do have two x squared terms, the 5x squared and plus 1x squared, so we get 6x squared. And we have the x terms, 6x plus 5x, which is 11x, and we just have 1, which doesn't have an x, so we just get the 6. And that is our answer. Now, the reason why we chose to isolate the x plus 1 rather than any of the other brackets is because here, when we're expanding, we don't have to multiply all of these terms by 2 or 3. We just have to multiply them by 1, which is easier. For example, if we had the 3 here, we'd have to multiply each of these terms by 3, which would be more work. It doesn't actually matter which bracket you choose, though. You'll always get to the right answer. Okay, so here are some exercises you can try. These two are for foundation and higher, but this last one is just for higher. Thank you for listening.